So we continue from where we stopped. And the type of fraction we are talking about today are those with nonlinear factors that are not repeated. There are fractions that have nonlinear, whose denominators are nonlinear and at the same time not repeated. We call that B. We call it type B. Fractions with nonlinear factors. Fractions with nonlinear factors that are not repeated. Let's take examples. Resolve let me say example. Resolve into partial fractions. Resolve into partial fractions. 1 minus 2x squared divided by x squared plus 1 times x squared minus 3x minus 2 1 minus x divided by x squared minus 3x plus 2 times x squared plus 4 times x squared plus 4. Now, let's solve these two. Let's solve these two questions. 1. How do you resolve this into partial fractions? 1 minus 2x squared divided by x squared plus 1 times x squared minus 3x minus 2. The first thing to check is what the type of denominator we have is. We can see that this denominator is a quadratic factor, which means it's a polynomial of degree n of degree 2. It's a polynomial of degree 2. That means n equals 2. And the general rule, I think I'll write that somewhere here. The general rule is that, let me write that, generally if the denominator of a compound fraction if the denominator of a compound fraction is a non-factorizable a non-factorizable polynomial. This means it's already in its simplest form and cannot be further simplified. It's a non-factorizable polynomial of degree n. Assign a polynomial of degree n minus 1 to the numerator of its corresponding partial fraction. Partial fraction. That simply means if the denominator is a non-factorizable polynomial of degree 3, its numerator will be the numerator of its partial fraction will be a polynomial of degree 2. If it's a non-factorizable polynomial of degree 2, the numerator of its partial fraction will be a polynomial of degree 1. So we now continue with our question. 1 minus 2x squared all over x squared plus 1 times x squared minus 3x minus 2. And the degree of a polynomial is determined by the highest exponent in the polynomial. So this is equal to the factor x squared plus 1 is a non-factorizable polynomial of degree 2. That means n equals 2. So the numerator of its partial fraction is going to be of this form: ax plus b. And that's ax plus b over x squared plus 1 plus the factor x squared minus 3x minus 2 is also a polynomial of degree 2. It's also a non-factorizable polynomial of degree 2. That means the numerator of its partial fraction is also going to be the most general polynomial of degree n minus 1, which is also of this form: cx plus d. And the partial fraction is cx plus d over x squared minus 3x minus 2. And now we can begin to solve. This means the LCM of the denominators is x squared plus 1 times x squared minus 3x minus 2. And that means ax plus b times x squared minus 3x minus 2 plus cx plus d times x squared plus 1 which means this means 1 minus 2x squared divided by x squared plus 1 times x squared minus 3x minus 2 is equal to ax plus b times x squared minus 3x minus 2 plus cx plus d times x squared plus 1 over x squared plus 1 times x squared minus 3x minus 2. And since the denominators are the same, that means the numerators are also equivalent. That means 1 minus 2x squared is equivalent to ax plus b times x squared minus 3x minus 2 plus cx plus d times x squared plus 1. Now, now I'm opening the brackets on the right hand side. I'm expanding the right hand side. And this simply means 1 minus 2x squared is equal to ax squared minus 3ax squared minus 2ax plus bx squared minus 3bx minus 2b plus cx cubed plus cx plus dx squared plus d. Now, I want to collect like terms on the right hand side. That means, this is supposed to be ax cubed. Collecting like terms on the right hand side. Ax cubed plus cx cubed minus 3ax squared plus bx squared plus dx squared minus 2ax minus 3bx plus cx minus 2b plus d, which is a plus c times x cubed plus minus 3a plus b plus d times x squared plus minus 2a minus 3b times x plus cx, minus that's supposed to be minus 2a minus 3b plus c times x minus 2b plus d. Now comparing the coefficients of x cubed. Comparing the coefficients of x cubed. The coefficient of x cubed on the right hand side is a plus c, but on the left hand side there is no x cubed term, so that means its coefficient is 0. So a plus c is equivalent to 0. That's our first equation. Comparing the coefficients of x squared. The coefficient of x squared on the right hand side is minus 3a plus b plus d. And the coefficient of x squared on the left hand side is minus 2. That means minus 3a plus b plus d is equivalent to minus 2. That's our second equation. Comparing the coefficients of x. Comparing the coefficients of x. On the right hand side, the coefficient of x is minus 2a minus 3b plus c. Minus 2a minus 3b plus c. And on the left hand side, there's no x term. That means its coefficient is 0. So minus 2a minus 3b plus c is equivalent to 0, which is equation 3. Now comparing the constant terms. Comparing the constant terms. The constant on the right hand side is minus 2a plus d. Minus 2b plus d rather. Constant on the right hand side is minus 2b plus d. And the constant on the left hand side is 1. That means minus 2b plus d is equivalent to 1, which is our fourth equation. Now we solve these equations to obtain the values of the constants a, b, c, and d. What I'm going to do is I'll make c the subject of equation 1 and put it in equation 3 to get another equation in terms of a and b. And then I'll make d the subject of equation 4 and put it in equation 2 to also get another equation in terms of a and b. Then I'll solve the two new equations in terms of a and b simultaneously. So let me show that from 1, c is equal to minus a. So I'm putting that c in equation 3. From equation 1, c is equal to minus a. Putting c in 3. Putting c in 3. Minus 2a. That means wherever I see c in equation 3, I'm going to write minus a. Minus 2a minus 3b plus minus a is equal to 0, which means minus 2a minus 3b minus a equals 0. And that means minus 3a minus 3a minus 3b equals 0, which is the same as a plus b equals 0. That's if I divide through by minus 3, a plus b equals 0, and that's equation 5. Now, from equation 4, d is equal to 1 plus 2b. I'm putting that in from 4. From equation 4, d is equal to 1 plus 2b. Now I'm putting that d in equation 2. From equation 4, d is equal to 1 plus 2b. Putting d in equation 2. What's equation 2? Minus 3a plus b plus d equals minus 2. That means wherever you see d in equation 2, you put 1 plus 2b. You write 1 plus 2b. So minus 3a plus b plus d, which is 1 plus 2b, is equal to minus 2. And this simply means minus 3a plus 3b equals minus 2 minus 1, which is the same as minus 3a plus 3b equals minus 3. Now dividing through by minus 3, I have a minus 3, a minus b rather. I'm dividing through by minus 3. That means a minus b equals 1. And that's equation 6. So I can now solve equations. I can now solve equations 5 and 6 simultaneously. These two equations. We can see that 5 and 6 are in terms of a and b. So I can solve them simultaneously for the values of a and b. Solving 5 and 6 simultaneously. Solving 5 and 6 simultaneously. What's equation 5? A plus b equals 0. A plus b equals 0. And equation 6, a minus b equals 1. So a already has the same coefficient in the two equations. So I can just subtract 6 from 5 to get b. So subtracting equation 6 from 5, that's the elimination method. A minus a is 0, and b minus minus b is 2b. So 2b equals 0 minus 1 is minus 1, which means b is equal to minus 1 over 2. Now, I can put b in equation 5 or 6 to get a. Putting b in, let me put it in 5. Putting b in 5, a plus b, which means a plus minus 1 over 2 equals 0. And that means a minus 1 over 2 equals 0, which means a equals 1 over 2. Now, we know c is minus a. C equals minus a, which means minus 1 over 2. And d is 1 plus 2b, which means 1 plus 2 times what b? Minus 1 over 2. Minus 1 over 2. Which is 1 minus 1. And that's 0. So we have all the values. We have the values of all of the constants. Then the compound fraction. Therefore, 1 minus 2x squared over x squared plus 1 times x squared minus 3x. Is that minus 2? Minus 3x. Okay, it's minus 2. Minus 3x minus 2 is equal to ax. A is 1 over 2. That's 1 over 2x plus b. B is minus half. So that's minus 1 over 2 over divided by x squared plus 1 plus cx. C is minus 1 over 2. That means minus 1 over 2x plus d, which is 0, divided by x squared minus 3x minus 2. And this is the same as x minus 1 over x minus 1 divided by 2 times x squared plus 1 minus x over x minus x divided by x squared minus 3x minus 2. You can see that this is the same as this is the same as x minus 1 over 2. This numerator is x minus 1 over 2. And if you divide that by x squared plus 1, this is what you're going to get. So that's it. That's the final answer. 1 minus 2x squared over x divided by x squared plus 1 times x squared minus 3x minus 2 is the same as x minus 1 over 2 times x squared plus 1 minus x over x squared minus 3x minus 2. Now we go to Roman figure 2. We go to the second. Let's solve a second question. Roman figure 2. Roman figure 2. And it is 1 minus x. Resolve 1 minus x divided by x squared minus 3x plus 2 times x squared plus 4 into partial fractions. And that's going to be equal to this denominator. This denominator can be factorized into x minus 1 times x minus 2. So that means we can rewrite the compound fraction as 1 minus x divided by x minus 1 times x minus 2 times x squared plus 4. If the denominator is factorizable, the first thing you do is factorize it. Now, there are 2 linear factors and 1 non-factorizable quadratic factor. So we can resolve simply. That will be equal to a over x minus 1 plus b over x minus 2, and the numerator of x squared plus 1 is going to be cx plus d over x squared plus 4. That's the numerator of x squared plus 4. So this simply means the denominator of the LCM of all the denominators is x minus 1 times x minus 2 times x squared plus 4. And that means a times x minus 2 times x squared plus 4 plus b times x minus 1 times x squared plus 4 let me move this back a little. Plus cx plus d times x minus 1 times x minus 2. Now, this means 1 minus x is equivalent to a times x minus 2 times x squared plus 4 plus b times x minus 1 times x squared plus 4 plus cx plus d times x minus 1 times x minus 2. So we can simply solve this by the cover-up method. Putting x equals 2. Putting x equals 2. That means 1 minus 2 is equivalent to a times 2 minus 2 times 2 squared plus 4 plus b times 2 minus 1 times 2 squared plus 4 plus cx plus d times 2 minus 1 times 2 minus 2. So 2 minus 2 is 0. That means the whole of this is 0. Same here, 2 minus 2 is 0. That means the whole of this is 0. So all we are left with is 1 minus 2 is minus 1 equals 0 plus, this is 1 times 2 squared 4 times plus 4, 8. 8 times 1 plus 8b plus 0. And that means minus 1 equals 8b, which simply means b is equal to minus 1 over 8. Minus 1 over 8. Putting x equals, what value can I put for x to get another constant? Putting x equals 1. Putting x equals 1. 1 minus 1 equals a times 1 minus 2 times 1 squared plus 4 plus b times 1 minus 1 times 1 squared plus 4 plus, forgot something here. I was supposed to put x equals 2 here. That would have been c times 2. Yeah, c times 2 plus d, which would have still been 0. Thank God that didn't change our solution. I should have put x equals 2 here. So c times 2 plus d. When you multiply that by 2 times 2 minus 1 times 2 minus 2 will still give you 0. So the whole of this is still, the whole of this is still 0. So this is plus c times 1 plus d. You just have to be very, very careful when you are substituting values for x. Times 1 minus 1 times 1 minus 2. So I can see that 1 minus 1 is 0, and that means the whole of this will be 0. And 1 minus 1 is 0 here, which means the whole of this is also 0. So I will be left with 1 minus 1, that's 0, equals 1 minus 2 is minus 1. 1 squared is 1 plus 4, 5. 5 times minus 1, minus 5 times a. 0 equals minus 5a plus 0 plus 0. And that means 0 equals minus 5a, which means a equals 0. So what's the next? What other value can we put for x to get another constant? Okay, maybe not really. At times when you put a value for x, it doesn't solve for any of the constants, but it simplifies the identity, and you can substitute the values of the constants that you have already obtained to get another one. So that's the kind of thing we are doing here. Let me put x equals minus 1. Putting x equals minus 1. Putting x equals minus 1. 1 minus 1 is equal to a times minus 1 minus 2 times minus 1 squared plus 4 plus b times minus 1 minus 1 times minus 1 squared plus 4 times minus 1 squared plus 4. I think I want to write my minus 1 squared this way. Minus 1 squared plus 4. And these two times minus 1 squared plus 4. Yeah, plus c times minus 1 plus d times minus 1 minus 1 times minus 1 minus 2. And this simply means 1 minus minus 1 is 2. 2 equals, this will be 1 plus 4, 5 times minus 3 minus 15 times a minus 15a minus 2, that's 5, minus 10b. This will be minus 2 minus 3, which is 6. That's minus 6c plus 6d. Yeah, that's correct. 6d minus 6c plus 6d. So we can now put the values that we already have, substitute the values of a and b. A, b, and can now substitute the values of A and B. Oh, okay. I could have put C equals 0. I could have put C equals 0 in. Alright, there's no problem. Let me just leave it this way. Let me substitute the values of A and B. And that means minus 15 times 0 minus 10 times B, which is minus 1 over 8. Minus 6c plus 6d. And that's equal to 1 over, that means 2 equals 10 over 8 is 5 over 4. Minus 10 times minus 1 over 8 is, 5 over 4. Minus 6c plus 6d. Which simply means 6c minus 6d is equal to 5 over 4 minus 2. And that's the same as minus 3 over 4. So that simply means c minus d. I can write this as 6 into c minus d is minus 3 over 4, which means c minus d is equal to minus 3 over 4 divided by 6, which is times 1 over 6. And that's minus 1 over 8. C minus d equals minus 1 over 8. Now, I just noticed I should have put x equals 0 to eliminate c. And that would have just given me an equation in terms of a, b, and d. And I would have substituted the values of a and b to get d. So let me do that now. Putting x equals 0. Putting x equals 0. 1 minus 0 equals a into bracket. Let's have the equation, the identity. 1 minus 0 equals a into bracket 0 minus 2 times 0 squared plus 4 plus b times 0 minus 1 times 0 squared plus 4 plus c times 0 plus d times 0 minus 1 times 0 minus 2. And this simply means 1 equals, that's minus 2 times 4, minus 8a. This is minus 1 times 4, that's times b. Minus 1 times 4 times b is minus 4b. Plus c times 0 is 0, so we have d times minus 1 times minus 2, which is plus 2d. And that means minus 8, I already know the value of a, times 0, a is 0, a is 0, minus 1 times a, and b is minus 1 over 8. b is minus 1 over 8. So minus 4 times minus 1 over 8 plus 2d. That means 1 is equal to minus 8 times 0 is 0. And that's plus 1 over, that's 1 over 2 plus 2d. Minus 4 times minus 1 over 8 is 1 over 2. And that means 2d is equal to 1 minus 1 over 2, which is 1 over 2. So 2d equals 1 over 2. And that means d is equal to 1 over 4. So c minus d equals minus 1 over 8. C minus d equals minus 1 over 8, which means c minus 1 over 4 equals minus 1 over 8. This is why I go by c minus d equals minus 1 over 8 from c minus d equals minus 1 over 8. And that means c minus 1 over 4 equals minus 1 over 8, which means c equals minus 1 over 8 plus 1 over 4. And that's and what do we have if we do that? Minus 1 over 8 plus 1 over 4, which is 1 over 8. Yeah, that means c is equal to 1 over 8. Now the compound fraction is 1 minus x divided by x squared minus 3x plus 2 times x squared plus 4 is the same as ax plus b. What is a? A is 0, so that means 0x plus b. What's b? B is minus, I think. Let's check that and be sure. B is minus 1 over 8. That's 0x plus minus 1 over 8 is simply the same as minus 1 over 8. 0x minus 1 over 8 divided by x squared minus 3x plus 2 plus cx plus d. C is 1 over 8x plus d. D is 1 over 4, but I want it to have the same denominator as c, so I'm writing it as 2 over 8, and that will be plus 2 over 8 divided by x squared plus 4, which simply means minus 1 over 8 times x squared minus 3x plus 2 plus x plus 2 over 8 times x squared plus 4. And those are the partial fractions into which the compound fraction 1 minus x squared over x squared minus 3x plus 2 times x squared plus 4 has been resolved. And that is it simply. It's as simple as that. So in the next video, we go to fractions with repeated factors, fractions whose denominators are repeated. Thank you very much. I hope you enjoyed the video. Thank you very much, and please subscribe and click the notifications icon to be notified as soon as new videos are uploaded. Thank you very much.